Hello guys, welcome to Electrical Preps. So we are going to solve this using substitution method, okay? And the question is integral of x on root of x squared plus 1 dx. So this, we are restricted to use substitution method, okay? We are restricted to use substitution method. So in this case, we need to let u to be equal to something, one of these terms, so that it can cancel out this x here, okay? So we can let u is equal to what is under the root, and that is x squared plus 1. Then we need to differentiate this, okay? But then let me show you something here. We know that integral of x on root of x squared plus 1 is the same as integral, sorry, the dx is there, the same as integral of x dx over root of x squared plus 1. I hope you agree with that, because we are going to multiply with this and we get this, okay? And this here is the same as integral of 1 on root of x squared plus 1 x dx, okay? So we can say that this is the same as this. Good. Knowing this, let's take it from, we said that u is equal to x squared plus 1. So in this case, the u ds is going to be 2x. So we make dx the subject. So making dx the subject, we're going to multiply both sides by dx. So we get du is equal to 2x dx. See? So in this case, looking at this, we have x dx. You see? So we can decide to divide both sides by 2. So dividing both sides by 2, we are going to cancel this, leaving x dx is equal to du on 2. So let's substitute this back into our question. So we are going to get integral of 1 on root of, now our u is this, so root of u, multiplying by our x dx, this one is now this, okay? So we replace it by du on 2. Okay, let's continue. Okay, so we had integral of 1 on root of u multiplied by du on 2, okay? So we can continue with this. We can say that integral, so 1 times du is du, okay? So du on 2 times root 2, root u is 2 root u. So we get 2 root u. Good. We can further simplify this. We assume that there is 1 here, so it's 1 multiplied by du. You see, 1 multiplied by du. So we can factorize 1 out of 2 from this function. You see, we can make 1 out of 2, we can bring it out. So we can say that 1 out of 2 integral, so it's left with du on root of u. You see, so that it will be easy for us to integrate. So we can say that this 1 on 2 integral, we can also make it 1 out of root u du, because 1 times du is du, so that we can integrate this with ease. So to integrate this, we get half multiplying by, so let me show you this. We have 1 on root 2 is the same as, let me do it here. 1 over root u is the same as u power negative half. You see, because 1 on root 2 is the same as 1 over u power half, like this, and it's over 1, so it becomes u power negative 1 on 2. Okay, so integrating this, we get u power negative 1 on 2 plus 1 on negative 1 on 2 plus 1 plus our arbitrary constant. Let's simplify this further. Get half multiplying by this, it will give us u to the power half, because half plus 1 is half, on half plus the c. Okay, so let's simplify the u on u power half on 1 on 2. So this case, it will be u power half on 1 on 2 is the same as u power half divided by 1 on 2, and it's equal to u power half multiplied by 2 on 1. So it's going to give us 2 multiplied by u power half, you see. So the whole thing becomes 1 on 2 multiplied by 2 power u this. So the whole thing becomes half multiplied by, let me bring the sign, 2 multiplied by u power half. Okay, so in this case, you can see that 2 will cancel out 2, leaving u power half. Okay, so in this case, we said that, oh, let's not forget plus our arbitrary constant. So we said that u is equal to x squared plus 1. So we need to replace u by x squared plus 1. So our final answer will be x squared plus 1 all power half plus c. So this is our final answer. Plus this, or you can rewrite it in a square root form. That will be root of x squared plus 1 plus c. So you can leave it in this way or in the original form, the square root. Thank you, and don't forget to subscribe. Bye.